So we're going to do wind, small scale and local systems. This is for ESCI 211. This is Chapter 9, Part 3. So after you finish watching this online lecture today, I hope you have a better understanding of the techniques used to record wind direction and speed, the instruments used to record the wind direction and speed, and how local wind systems are created. All right, so how we determine direction is these compass headings. So how we determine direction are caused by these compass headings. We characterize wind by three factors: the direction, its speed, and its gustiness. Gustiness is how its speed can change over time. So wind direction is determined by the direction from which it blows. So just like in this compass reading, the arrows go from the north to the center or from the east to the center. So an easterly wind has to come out of the east and flow towards the west. So using that same analogy, an onshore wind is a wind that blows from the water to the land, and an offshore wind is a wind that blows from the land to the water. One of the ways we figure out the prevailing wind patterns is for a given wind direction is that we use this instrument called a wind rose. So we record the wind direction for a given period of time, and the larger the line here, the larger the line, is the more times we recorded the wind coming out of the northwest towards us. And when we do this over time, we will find out which direction holds the prevailing wind, and it ends up being, for this picture, out of the northwest is our prevailing wind pattern. All right, instruments we use. One of the instruments that we use is called a wind vane, and this is a wind vane right here, and it helps us to determine the direction of the wind. Another instrument is an anemometer. This is an anemometer, and this allows us to record the wind speed. And another type is an arrow vane. So this is an arrow vane. It allows us to do the wind speed and its direction at the same time. Other instruments we use, something called a pilot balloon. Basically, they fill a balloon full of helium and release it, and then they track this balloon with a telescope as it moves away, and then they record this and figure out its direction and wind speed. Another instrument is called LIDAR, and this is a remote sensing instrument. LIDAR is like radar, except for using electromagnetic radio waves is radar. Instead of using radio waves, this uses visible light waves or infrared light or ultraviolet light to determine wind information like speed and direction. And if you get the right wavelength, you can actually track molecules of air, which is helpful. And then the last one everybody should be familiar with is the Doppler radar they always show on the news, and we can use that information to help us get wind speed and wind direction. All right, we're going to talk about local wind systems, or how we create local wind systems. Now I want to stress before we start, this is a very important idea in meteorology. So I need you all to learn this material. If you don't understand it after the end of this, I need you to ask questions. All right, so let's get started. This is usually referred to as thermal circulation. So what's going to happen is the sun's going to come out and warm the surface. Okay? And there's different pieces on all surfaces, and as the surfaces heat, each surface area might have a different albedo. So each location surface might absorb different amounts of solar radiation or absorb enough energy from the sun. What's going to happen if you have an object that absorbs part of the surface can absorb more energy, then you're going to create a thermal low. The warm air rises, so we're going to get a low on the surface, and then we'll get a high above it, some distance above it in altitude. And then if you're over a part of the surface that reflects more of the incoming radiation, it's going to be colder, so we're going to get a thermal high on the surface and colder air, and you'll get a upper level low above this surface high. All right, so here's what's happened. So just a reminder that warm air rises and cool air falls, and this helps us creates creates highs and lows called thermal highs and lows. So over the warm air, you get an upper level high, and over the cold air, you get an upper level low, and the pressure gradient force is going to blow from the air, from the high to the low. Okay. And what's going to happen over time is that the air coming into the low has got to go somewhere. It can't go right over it because it wouldn't be a low. The only place it can go, it can't go up because that's hitting, would go into the ceiling or into a region of the atmosphere that's not going to let it to go up. So the only place we can have is it can go down. So it's going to flow down, and this is going to cause a surface high there. And then over here on the upper level high, the air is blowing away. Now in order to keep that high there, it's got to get air from somewhere, so it's going to get it from below, and the air is going to move up. So if it gets it from below, this creates a thermal low at the surface, and we get this pressure gradient forces between them, and you get this circulation pattern that comes up. So all circulation patterns in the atmosphere are going to revert to the same idea. We're going to look for thermal highs and thermal lows, and then above them in the upper atmosphere, above a thermal low, you're going to have an upper level high, and above a thermal high, you're going to have an upper level low, and it creates this type of flow pattern. All right, so I hope you have a better understanding of the instruments used to record wind direction and wind speeds. I hope you have a better understanding of the techniques we use to keep records of the wind direction and wind speed. And I'm also hopeful that you have a better understanding of the local wind systems and how they're created. And basically, the main creation is differential surface heating. One area will absorb more energy than the other, and that will become warmer than the other areas and will create thermal lows and thermal highs. At the end of part 3. I hope to see you in part 4.